Scholar IT Solutions is a balanced staffing company developed by a group of professionals with an experience of over 18 plus years in staffing solutions. With years of quality and committed high-end application development and staffing experience, we have become experts at delivering the right fit, the first time. We will be glad to be your last stop and provide you with the perfect solution to your requirements. Follow Scholar IT Solutions LinkedIn page for more updates. Follow our social media pages.
IT solutions provider back in the US, they have a really great technical team, which has, tons of domain experience, be it database, Windows, cloud, and all, right? So they have quite a big team, and Venkat has been doing a great stuff there, and entire Scholar IT team, I would say. So thanks Scholar IT for giving me a chance to speak here. Do not forget to follow Scholar IT on social media network. All right. So someone must already have put links in chat window, I guess. Yeah, Karthik did. So make sure you go and follow them there. All right. So so today's session is on Azure SQL. This is gonna be an introductory session. You will be introduced to Azure SQL. I'll give some overview on most of functionalities within Azure SQL. What Azure SQL is, what the security in Azure SQL, backup, restore, HADR, or that kind of stuff. At some places we'll go a bit deeper, so you know how you can differentiate between your on-prem SQL Server and between your Azure SQL, right? So some places I'll go a bit deep, so you have a better understanding, right? We are planning to continue this series, starting from this introduction and then moving ahead with each topic covering in a session, so you can basically understand it as whole. All right. So about myself, so I have over 11 years experience. I worked on SQL Server. I started my career as a SQL Server developer. Then I moved to administration. I worked starting from 2000 SQL Server, and until now 2019. Right. I also SME in Postgres, MySQL, Mongo, Cassandra. I am a solution architect in Azure. Along with that, I also have Azure administrator. Being an Azure database administrator, right? Being a core field, being database being my core field. I also have certification in Cassandra administration. Right. Right now, I work in the capacity of database operation manager. I oversee multiple teams, ranging from L1 until L3 and SMEs. All right. I basically support hedge fund clients back in the US, Europe. All right, even in Asia as well. You can follow me on LinkedIn and on Twitter. I am particularly, a bit more active on these platforms, right? You might want to get these email IDs and contact information noted if you want to connect back with Scholar IT for any of your training or what needs, whatever that is. All right, let's get started then. So guys, I'll try and cover everything within basically an hour or so. So it may go beyond an hour, but I'll try and finish it within an hour. All right. So we'll have a bit of a lot of theory, because this is an introduction session. At the end of the session, before closing this out, I'll take you to Azure portal and we'll spin up Azure SQL instance. We'll set up some HA and solution over there. All right. So Azure SQL. What exactly is Azure SQL? So the content for today's session, Karthik has posted in chat. Let me show you. So today we are going to cover what Azure SQL is. All right. The history of Azure SQL. Give me a second, guys. No. Give me a second. So not all right. Sorry for the hiccup. All right. So the history of Azure SQL, that's gonna be what exactly is Azure SQL, what are its deployment models, right? We will go into security, HADR backups, as I told you, right? So let's start with what exactly is Azure SQL. Someone has a question? All right, guys, if I have to chat or speak up, and otherwise, please keep yourself muted so you don't have a noise. All right. So what exactly is Azure SQL? So first of all, Azure SQL is a fully managed fast service, fast database engine that handles most of the database management functions. That handles. I mean, you don't handle that. All right. The functions can be upgrading, patching, backups, monitoring without user involvement. All right. So what? Let me tell you guys some differentiation. What exactly is PaaS and other the solutions are IaaS, infrastructure as a solution. This is platform as a service, and other thing we have a SaaS, software as a service, right? So the PaaS is where you don't have access on OS, the underlying OS, the underlying hardware. All right, that's called PaaS. So all OS level activities are taken care of by your cloud provider, your service provider. So here in this case, that would be Microsoft. So it is a Azure SQL is fast service. So everything, including patching, backups, and everything, are done by Microsoft without your involvement. All right. Azure SQL database. This always runs on latest stable version. Okay. Of data SQL Server database engine. So even your most latest version of your on-prem database SQL Server may be a bit behind than what is available in Azure. So Azure database is the latest stable version of your SQL Server engine, right? And even the OS. So what is PaaS basically? So there is let me, yeah. So there is a logical server, all right, which you don't have access to. And then there is a SQL Server installation on top of that logical server. This is what you have access to, and this is the PaaS. So basically, this database engine is patched with the latest version, and this OS is always patched with latest service packs, cumulative updates, and everything. All right. So third thing is the Azure SQL not only supports relational data, but it also supports non-relational data. That is XML, JSON, graphs, and this sort of data, All right. And since this Azure SQL is based on latest stable version of SQL Server database engine, you can use all latest advanced query processing features like, high performance in mem, intelligent query processing, all the new inventions which comes into SQL Server on-prem. First, they come to Azure SQL. All right. So this is what Azure SQL is. Now, there is no physical hardware, obviously, because the hardware and the OS is managed by Microsoft, not by you. You don't have access to. All right. You just have access to your own instance over here. Now, you have multiple flexible deployment models. In Azure SQL, you have single database, you have elastic pools, serverless, managed instance, and managed and instance pool. All right. We also have something called Hyperscale that also we will discuss about. This Hyperscale comes into, I would say, comes along with serverless. Okay. So that's also the part of single database offering. All right, serverless is also part of single database offering. Cool. Now it supports variety of data. It is affordable. Now, why is it affordable? Because when you are planning to spin up an instance in your own environment, you are buying hardware for that single instance, right? Single installation, single. I would say installation. Let's go with installation, right? So you won't get the hardware cheaper. Then you will have to pay for OS, for your license fees and everything. Other than that, you will also have to hire some experienced people to handle OS, to handle your networking, all that stuff, right? Here, you don't have to do that at all. You just pay for the database, for the space you use, right? You don't have to hire specialized people. And that too, this is some places you are paying per second, you are paying per hour, right? So it is affordable, because if you don't need anything after a certain period of time, you can just destroy that data, right? In your on-prem case, you will have to keep that hardware with you, no matter if your project lifetime is just 6 months. You'll have to pay a one-time license fee for Windows, for SQL Server, and everything, right? Now, it is highly scalable, way better than your on-prem servers, right? Or for on-prem server, if you want to scale that out or scale that up, you will have to take approvals. Okay, approval may still be necessary here, but then you will have to go and purchase additional hardware and additional RAM or whatever you want to put in your machine. Or if you want to have an scaled out HA, if another server, let's say you have a standalone server, you're going to put that in always on availability groups, you'll have to buy another server, right? So here you don't have to do that. You just spin up another database and you can just have high availability there, right? It's reliable because Microsoft promises you a certain SLA that they will give you 99.94% SLA with Azure SQL database, 99.99% SLA for Azure VMs and all, right? And then they have tons of background processes, tons of background, basically monitoring and everything, which makes sure that you are provided your SLA, all right? The promised SLA. So it is reliable because there is a big giant company in background making sure that you don't get downtime more than promised, right? It is highly available. Each thing in Microsoft, in Azure, I wouldn't say Microsoft, in Azure has at least 3 copies of it in background. So your Azure SQL database, you are working on one single instance, but Microsoft copies your data to 3 different. I mean, this is the primary 2 more places. So everything has a redundancy, all right? So if something goes wrong, you can just, Microsoft will spin up another instance for you. And highly available, you can have basically sync replicas, right? So you can have them as, those can work as an HF for you, right? There are multiple ways with multiple products, multiple services in Azure, which provides your Azure SQL instances. Those protect your Azure SQL instances with multiple intelligent algorithm running behind them. All right, so you get intelligent production along with Azure SQL. All right, now let's go and dig a bit history of Azure SQL, how it all was planned, how it all came into life, how its evolution has been, right? So it didn't really start in 2006. It's the foundation of Azure, whole Azure was put back in 2005. So what happened? There was engineer. I wouldn't say engineer. The guy, he was an architect, a big head architect in Microsoft. His name was Ray Ozzie. So he was the main chief architect of Microsoft back then. What happened is that one day he just sent out an email to a set of executive in Microsoft, and the email subject line was internet services disruption, right? So in that email, he wrote that we as a product company are already on top, but where do we see ourselves in future? All right, what products should we bring in which values customer way more than we do today, right? And he actually wrote indirectly, not directly, the potential of cloud in that email. And that was when Microsoft started thinking in a different, altogether different domain. They started thinking, okay, how can we reach out to those people who do not want to, stay with this basically monolith applications, or on-prem applications, I would say, right? So that was the email which triggered this evolution where we are today. Now in 2006, same guy Ray Ozzie, he replaced Bill Gates. So Bill Gates was chief software architect in Microsoft back then. He replaced Bill Gates that time, and then he started working on a product, and that we today call Azure. Okay, so that's how it was born back then. Now, in same 2006, what Ray did, he pulled in a senior architect from Microsoft called Peter Shapiro. That guy was responsible for the release of Microsoft 7.0, 2000, and including 2000 and in 2005. Okay, he was the chief architect for those releases of Microsoft, the SQL Server. He pulled him in, and he said, "You are gonna lead. You will be the chief architect for a project, and that would be, and you will be the responsible person to take SQL Server in cloud." Back then, they didn't say cloud, but the meaning was cloud, right? And that time, the project was called Cloud DB. Same time, Ray also pulled in old Microsoft guy called Amitabh. His exact name was Amitabh Srivastava, right? And he was handed over a project to take OS to cloud, and the product was called Red Dot. All right. So Amitabh Srivastava for Windows, and Peter to SQL Server. All right. Now in October 2008, they basically went GA, and they announced Windows Azure and SQL Server data services. Okay, this was a conference, Microsoft Professional Developers Conference in Los Angeles. There they announced this all stuff. All right. Now here in 2010, they changed SQL data services to SQL Azure launch. All right. Now, this SQL data service specifically, it was a combination of data sync, reference data, reporting, ETL, all that stuff. It didn't really have what we have today. All right. Now, in 2012, the database was rebranded to SQL Azure. Okay. Here it was SQL data services, SQL Azure launch. They didn't really say it's SQL Azure, SQL Azure launch, and it was renamed as SQL Azure. In 2013, it was a major release of Azure in terms of SQL Server. They brought in Azure Virtual Machine as infrastructure as service offering, and at that time you could have your SQL Server in Azure Virtual Machine. Before then, what was happening that everyone was just restricted to SQL Azure, and the problem here was that it was not that highly scalable. You couldn't just go in and have, let's say, in virtual machine, what you could do, you could add multiple disks, right? You could have your own choice of SQL Server version, right? Addition. Here you don't have that choice. All right. So that was a basically revolutionary, milestone for Microsoft there. Then 2014, here they again, it was said. Windows Azure was changed to Microsoft Azure. At the same time, in 2014, what happened that in SQL Azure, they brought in two tiers. One was web and one was business tier of Azure SQL database. At that time, your web tier was just supporting, I guess it was somewhere near 1 gigabyte, 10 gigabytes, sorry. The web was 10 gigabyte, and the other was business, that was 50 gigabyte. Soon after, they upgraded business to 500 gigabyte. All right. And then we have got Azure SQL Database version 12 and all that stuff, Then version managed instance in 2018, Elastic Pool in 2016, and now we have in 2019 we got Hyperscale serverless and managed instance pool. We'll discuss all about these. All right. And today we have Azure Arc-enabled Azure, where you can basically deploy your Azure on the hardware of your choice. You can even deploy Azure on your on-prem server, okay? And then you can sync those back to cloud, okay? There are two kind of modes, connected and disconnected. When disconnected, you can just connect that once, so that it can sync up to our, repo over on Azure, and connected, that will already be synced. So that's a bit of history, how this all born. All right. Now, what kind of deployment options do we have in Azure SQL? All right. Now we have SQL virtual machines. We have managed instances, and we have database. Now, what this database is single database and Elastic Pool. In many instances, we have single instance and instance pool, and in there we have SQL Server in Azure virtual machines. Now, this specific thing here, this is infrastructure as a service offering. Here you have access to OS. Only thing you don't have access to is hardware, networking. Though you can set your networking up at the way you want. You can set the hardware up the way you want. Let's say you have a choice to choose between hundreds of different VM sizes, right? Based on CPU, based on memory, number of disks supported, the IOPS, number of IOPS, what kind of disk managed, unmanaged, managed. You have premium SSD, ultra disk, and normal SSDs, or even hard disks, right? So you have multiple choices here. Now, Azure database. This is the PaaS offering. This is again infrastructure as a support, infrastructure as a service offering. This is the platform as a service offering, and this as well. Here you have an option for a single database, right? So what happens in single database, that Azure still have a server running underneath, okay? That's a VM on Azure Infra. Once you start your single instance, what happens is there are multiple, these VMs are already running. What happens, it quickly deploys an instance, a logical server. The server is a SQL instance for you, where you can have your database, okay? Sometimes this database can also be shared with other people on same server. That's why the deployment of Azure SQL database is fairly quick. But there are multiple instances running, and then you share your database with other people there. All right. That's why it's easy. It just has to create your database. It just has to put in some background rules. And how does it do that? It uses resource governor. You must have heard about resource governor in SQL Server, right? It uses same in background to, so whatever tier you are choosing here, right? So it uses resource governor to cap your uses to that particular tier, whatever you are going to use, right? Going to put your single database in. All right. So you can have multiple single databases. Okay. So what happens is, if you have a single database, now whatever tier you buy the single database in, you will be charged for that tier. All right. Then you have Hyperscale as part of single database. You have serverless as part of your single database. Okay, we will discuss more about these two offerings. Then you have elastic pools. Now what happens is that the single database, as I said, you are charged whatever you choose for a single database. Now what happens is you have multiple databases, and the uses of those databases unpredictable. Sometimes they need tons of resources, and sometimes they are just ideal, sort of ideal, not really ideal, right? At that time, what happens is, if you are using single database and you have X basically purchasing model service tier, then you are charged for X purchase model. Now what happens is, in this elastic pool, you can buy a big X service tier. Okay. Now what you can do is, you can put your unpredictable use database in this single tier. Now you will be charged for whatever you use here. Okay. Now what happens is, we'll discuss about more about it in next slides. Let's not dig here. Now single, and then this. Okay. When you are migrating to Azure, okay, and you just want that, I don't want to lose any functionality from what you have right now on an on-prem server, then SQL Server in virtual machine is the place to go. All right, because this is same. You have OS, and then you install SQL Server on top of that. Or what you can do, you can choose a Windows image with pre-installed SQL Server. Okay, you just have to do some post configuration stuff. That's for some different day. All right, so you can just lift and shift here. Okay, so this is kind of a replica of your on-prem. The thing which you are getting here is the HA provided by Azure. You can automate fetching here, so you don't have to worry about that. All right. So that's your lift and shift solution. If you are trying to come to cloud without worrying anything at all about how it's gonna be when we move from on-prem to Azure. Now the second closest relative to your lift and shift stuff is managed instance. So what managed instance is? It's a PaaS offering. Okay, it's as good as SQL Server in virtual machine, but only thing different here is you don't have access to OS. All backups, patching, everything is done by Microsoft. Here you are responsible for that. You are responsible for your security. You are responsible for your patching. You are responsible for your backups and everything. Here you don't have to worry about backups, patching, all that stuff, consistency checks, CheckDB and all. Right? You don't have to worry about that. You lose a bit of functionalities here, but you get your SQL Server agent. You can put your SQL Server agent jobs here, all right? And you get your cross database queries. You get your CLRs, all right? You can load CLRs here, and then you can here you can't just use CLR straightforward, right? There are ways. So this is your second option if you want to come to cloud, and you don't want headache of taking backups and patching and all right? Now that's your Azure SQL managed instance. Now on single instance, you can host multiple databases. It's unlike single database. It's a single database. It's a single instance, like a SQL Server instance. You can host multiple databases here, all right? It gets the VNet security. Here you just get some firewall security. Here you have option to get secured via VNet, all right? Now, what is instance pool? Now, instance pool is again kind of elastic pool. It is a pool. You choose a pool. In this pool, you choose, okay, I need these much of CPU cores, this much of storage for this pool. Okay. Now, what happens? Usually, if you are going with SQL managed instance, I'm not sure how many of you have already tried spinning up a managed instance. First of all, it's expensive as hell. I mean, for a testing purpose. So I have Microsoft provided, some free credits every month to me, so I can spin up, but I don't have courage to spin it for more than 3-4 days because this is really expensive. Okay, and it takes up to 6 hours to spin up this instance. Now, what happens is if you are in such a company where you may have to spin up manage instance multiple times a day, or maybe multiple times a week or something like that. So what you can do is you can create an instance pool upfront with required resources, what you need, and then what you can do is you can deploy your SQL managed instance within this instance pool, and that is really quick. So what happens is when you start this instance pool, here what is happening? It's creating a virtual machine, it's installing Windows, it's installing SQL Server, it's doing all the installation, it's setting up everything for you. Okay, backups, everything in background. We are Microsoft, Azure Service Fabric. That's doing everything. Now here, what happens is that time is taken only once. It spins up an instance for you, a complete big VM in background. Now what happens is whenever you need a SQL managed instance, you just create a managed instance here. That will be just a SQL installation. That's a way lot quicker than spinning up entire single instance. Okay, so that's instance pool. Right now, it isn't available to be created via portal. You can only create it via PowerShell. All right. So this is all about this slide, guys. Any question here? All right. Now, purchasing models. We have two kinds of purchasing model. We have DTU based purchasing model. We have vCore. The DTU is the older one. Okay. Now, what exactly is DTU purchasing model? Here, what happens is, what does a DTU stand for? The DTU is database transaction units. What happens is, DTU is a kind of basically a DTU contains a specific number of cores, a specific memory, okay, IOPS, specific IOPS. So that the club, if we club this all together, that we call a DTU. Okay, so it's kind of a mixture of all these. Okay, now what happens is if you have a choice to go with 5 DTUs, 10 DTUs. With the number of DTUs you use, you get a specific amount of RAM, CPU, and IOPS. All right. So that's about DTU. Now we have multiple models here in DTU. We have basically basic, premium, and standard. Now in basic model, you have certain limitations. We will discuss about them in next slides. Okay. Now in vCore, here what happens is you will choose how many number of vCores you need for your deployment. You need 4 vCores or you need 8 vCores. I think we can go as high as 80 vCores. Here, I think we can go as high as 3,000 DTUs. Okay. So this is about DTU. This is about vCore. And this is the older model. This was introduced back in 2010 or something. All right. Even before that. So now in DTU, you have basic model, purchasing model, you have standard, you have premium. In vCore, you have general purpose, business critical, and hyperscale. Okay. Now in general purpose, you have 2, provision and serverless. Now this provision is the one which I was talking about, the single database, where you just provision resources upfront. Okay. And the database which you create, you put those, the data which you put under this provision purchasing model, that will be charged for those number of resources. Okay. Serverless is something different. We will discuss these in detail. Now in provision, even your VMs also come, because VMs are also vCore. You choose the cores, right? Number of cores for your VMs. Okay. Now this Gen 5 is for these 2. You can only choose Gen 5 hardware. Now these are the VM sizes. Same goes with business critical, and these are the VM sizes. Okay. Now the DTU based model. Here I have differentiated, each model. Now in basic DTU based model, you get maximum 2 GB of storage for your database and maximum 5 DTUs. Now, if you are asking me how many CPUs you get in each DTU or how many memory you get, there is no way to calculate. Microsoft hasn't provided any way. If anyone is telling you that this is the way, I have multiple ways to prove them wrong. Okay, many MVPs and MCTs have tried to get a perfect baselining for DTU, but all results came with different, all tests came with different results. All right. So though if you want to understand is, then 100 DTUs, okay, of premium model are equal to 1 vCore. Simple. Okay. 125 DTUs of standard model are equal to 1 vCore. Okay. You get better CPU in premium model. Okay. The high-end CPU. All right, so sorry. So max DTU are 4,000, not 3,000 in premium model. The max storage size you get is 4 TB in DTU based model. All right. So this is now the target workload for each kind of purchasing model in DTU. For basic, you can use it for development and production even, but for production it is not recommended because 5 DTUs. You can just use some test database here, right? Well, you will exhaust those 5 DTUs like nothing. It won't be even 0.5 vCore to be true. Okay, you get 99.99% availability here. The backup retention is 7 days, 1 to 5 IOPS per DTU. This is the read and write latency. You can read. There is no support for column store index. There is no YAM OLTP. Here, the backup retention is more. Okay, the IOPS is same. Read write latency is same. You get column storage indexes over S3 and above purchasing model. Okay, now what is S3? Even standard has been categorized between multiple S0, 1, 3, 6, 9, 12, like this. So each model, as high you go, so this one TB and 3000 you get with the maximum, on the top level of a standard purchasing service tier. All right. Now in premium you get all of this stuff. You get maximum 25 IOPS per DTU, 2 millisecond latency for both read and write, in-memory OLTP, column store, all are supported. All right. Now, if you are going with elastic pool, this is all true for single database. Now, what about elastic pool? So we'll discuss more about elastic pool, but for now, just understand what are the limitations. So if you have elastic pool and in DTU model, you get 2 GB storage per pool, not per database. 156. Sorry, per database is 2 GB, per pool is 156 GB. Per database DTU, now the DTU, those are not called DTU, no, those are called eDTU, elastic DTU. All right, 5 per database, 1600 per pool. The per pool databases are 500. Now, same way here and here. Okay, Now, this we already discussed. Okay. Now, purchasing model we already discussed in detail. DTU base was discussed here. Now, in vCore, what do we get? We get general purpose, we get provision, we get business critical, and we get hyperscale. Now, in provision, what happens is you are billed per hour based on vCores configured. Now, if you have, let's say, 40 vCore configured for your single database, in vCore model, you are charged for 40. Okay. Now, in serverless, you are billed per second based on the vCore used. Okay? Understand the difference here. Here, the vCores configured, here vCores used, not configured. You may configure 80 vCores for your serverless server, but if you are using only 2 of them, you are charged for 2. And if you use 40 at particular moment, then you are charged for 40 at that particular moment. Well, it charges per second, not per minute, not per hour. This charges per hour. No matter, even if you are configured for 40 and you are just using 5, you will be charged for 40 for entire hour until you degrade it and go back to your 5 vCores per for that particular server. Okay. Now you have a new functionality in serverless that's called minimum auto pause. That's called auto pause. Now there is a minimum auto pause buffer time, that's 1 hour minimum, max is 7 days. We will see what does it mean. Let me quickly though show you that. Let me quickly pull something for you guys here. So let me go and create it here for you guys just to give you a quick rundown here itself. Okay. All right, I'll choose same resource group. I'll choose any database name. I'll say some server. Okay. RST Server 2021 maybe. Is that good? All right. Now configure database. Now here you will see. So we have vCore based purchasing model. We have DTU based purchasing model. In basic, as I told you, you have maximum 2 gig of space. You don't get more than that. All right. Now, if you go for standard, you can get up to 3,000 for S12 and 1 terabyte of space here. All right. Now, if you go back, the space reduces. Look at, keep an eye here. This start reducing. Okay. Now here you can have 1 terabyte for S7. All right. So after S7, you can have that, but as soon as you move back to S4, S3, okay, and the S3 also you have. S3 you have 250. Now, for premium model, you have 4,000 for P15, and you have 4 terabyte storage. All right. Now, this also provides. Let me show you this here. One more thing, guys. Sorry. This basic DTU model doesn't provide you zone redundancy. That's again an HA feature. That's why never ever use it for your production workload, because what happens is if something goes wrong with the data center which you are configuring your this instance in, your database won't come online because you did not configure anything here. All right, you go for standard. You also here you don't get zone redundancy. What if your zone is down, your data center is down? All right, when you go to premium model, you get 2 more things. First of all, what you get a read-only replica. Okay. You can have a read-only replica here. Second thing, you get zone redundancy. What if your entire data center is down where your primary lives in? You can still scale out your. You will have a secondary running in another zone. All right. So that's what you get with premium. Now go back to vCore. You get general purpose. In general purpose, you have provision and serverless, which you were just talking about. Now in provision, you are charged per hour, whatever you are allocated for. Now in serverless, so in let's say this is, you get maximum 80 vCores and you get 4 terabyte of space. All right. Now you also get zone redundancy here. Okay. No matter you are going for 2 vCores, you can go as low as 2 vCores as in 30. Okay, 1 gigabyte as well as 1 gigabyte. That is charged 1 hour. Total monthly charge is 26,130 rupees. All right. And this is charged per hour. So if you want to go in and try it, you can go in and try. This also comes with zone redundancy. Now, if you want to go with serverless, now the difference with serverless is you get something called auto pause delay. Now we'll discuss about this. I just wanted to show you where do we have this option. You also get zone redundancy here, right? You don't get a read replica. Okay. Now if you go to business critical, hyperscale, something different, we'll discuss. Here you get your read replicas. Okay. Also zone redundancy. That's there for every one of these. Now let's go back to PPT. All right. I hope you understood. So in hyperscale, so we have some PPTs next. I'm not discussing these now. We'll discuss it in their respective PPTs. All right. Now let's go back. Go forward. Now Azure SQL VMs. Discuss in detail. This is the infrastructure as service option to deploy your SQL server in Azure. The hardware is managed by Microsoft. Rest everything is managed by. The hardware, even the networking hardware is managed by Microsoft. But the networking rules, the security is set up by you. Okay, you can install SQL Server here after creating a VM, or you can choose some VMs which are pre-bundled with SQL Server. Okay, they have pre-installed SQL Server. I mean pre-bundled, not installed. When you create that VM, that gets installed there. All right, you can bring your own license to reduce license cost. You can bring your OS license. You can bring your SQL Server license from your on-prem. And you can save your 50% cost. Okay, this is the best option for your on-prem SQL Server lift and shift. You can also have automated patching and backups here. Okay, read caching can be enabled for data disk or better performance. So what is read caching? What happens is the data which you are, and this is not available for the this is highly not suggested for the disk which contains log files, because you don't want your logs to be put in read caching. Okay, because you don't need to read logs. Only time you need to read logs is for when you need basically recover your database. But the thing here is, guys, when you have read caching enabled, the data is written to your cache of your disk, not to your data files. Even the write happens in cache, but because your log files are not read caching enabled, your log drive is not read caching enabled, your logs are written to your log file. Now all RDMS being write ahead logging enabled, everything. I mean, you guys must already know what write ahead logging is. You write the logs first before writing the data in data files, right? Since your logs, your all RDMS supports WAL, write ahead logging, right? So in this case, even if data is written to the disk cache, the data for data files, all right, not the logs. Even if something goes wrong with your database, right, your log file can still be used to replay those logs and bring your database online. All right. So how does this help? What if the data which you are writing is required for read at the same time? Now the server won't have to go to disk and pull data from the data file, right? It can get that from the disk cache itself. That's why this is good stuff. Now you can set up your ad hoc backups, and those backups can be taken to Azure storage account. You can have your always on failover cluster instance. This is failover cluster instance, not always. Always on failover cluster instance, not always on availability group. Okay. You can use premium files here provided by Microsoft, provided by Azure, as your cluster storage, and you can still have your failover cluster instance. You can set up your availability groups. Okay. You can have your TD supported here. Okay, this is not enabled by default because again the security is managed by you, not by Microsoft. Okay, now what you can do is you can use Azure Key Vault. You can create your key there. You can create your certificate put there. You can integrate the key vault with your Azure VM. You can enable TDER and route all those encryption queries to Azure Key Vault to get authenticated. All right. So this is about Azure SQL VM. This is your first solution for lift and shift your on-prem database back to Azure. Now you have Azure SQL database single instance. Okay. Now this is the DTU is based on service tier. Okay. We just saw it supports up to 4 TB. We have something called Hyperscale, which we will discuss. This supports up to 100 TB per logical database per logical server I5000. As I said, when you spin up a single database, all right, instance is created in background. Okay, you can host maximum 5,000 databases in that instance. Max DTU or eDTU is 54,000 per server. Okay, multiple log files are not supported because why? Because you don't have access to OS or storage. You just create database, Microsoft or Azure takes care of everything, data files, log files, and everything. Okay, now it uses availability groups in background to support promised SLA. What happens is when you are spinning up your instance, in background, always on availability groups are used to to ship your transaction logs to hidden secondaries. In case of this server or this data center going down, Microsoft will bring up these instances and these will become your primary. Okay, so they can provide you the promised SLA. Okay, now data is stored on GRS storage blocks. Now what is RAGS? This is read access geographical resource, replicated storage. Okay, now the data is replicated to the paired region. Let's say you are in East US. Okay, now the data may be replicated in US2 region. Okay, the data is replicated there. It supports your application and point in time recovery. It supports automatic patching because that's fast service. It supports you can bring your own license. Okay, and even get it uses built-in license. You pay whatever you use, pay as you go. Right? There is no SQL Server agent or database mail or link server. If you need any of these agent functionalities, you can use Elastic Jobs or other stuff which is out there to set up your jobs and all. Okay, it is TDE enabled by default. Now this TDE, the key is managed by Azure. You have an option to bring your own key. That's called customer managed secure. The customer managed key. You can bring your key, put that in again Azure Vault, integrate Azure Vault with your Azure SQL database, and get authenticated from there. All right. Now you can restore or point in time restore only to it is only possible using portal. And let's say the backup retention, maximum backup retention in Azure SQL is 35 days, not for Azure VM, because their backups are something which you can control yourself. Okay. Now the more is your backup retention, the more is your PITR. If you have 35 days of backup retention, your PITR also goes as back as 35 days. If you have 7 days of backup retention, your PITR goes as back as 7 days. Because Microsoft will only keep your backup up to 7 days. Backup for point-in-time recovery, not long-term backup. There's something else which is called long-term backup. That's something else. Okay, we will discuss. It only supports full recovery model. Azure SQL database can be a subscriber for transactional or snapshot replication, not publisher, not distributor. Now, Azure SQL Elastic Pool. What happens is it's best suited for databases with varying and unpredictable usage demands. Okay, we'll see in next slide what that means. Database in Elastic Pool are on a single server and share a set number of resources at set price. Minimum and maximum DTUs or maximum vCores are set for each database in a pool. It supports PITR, geo restore, and active geo replication. Now, let's say you have a single database. At one time, it uses 90, let's say DTU. At one time, it uses 50 DTU. Here, 50. Here, 0. At this time. Here, just 10. Here, just 50. Okay. This is here. If you are using single database, you are even paying it here. Let's say the single database is using 90 DTU. Let's suppose. Okay. Now, no matter you are using the 50 here, no matter if you are using, let's say, vCore, you are using 4 vCores. Okay. And that's where it exhausts those all 4 vCores. But here it is ideal. You are still being charged for 4 vCores. Okay. Now, in Elastic Pool, what can happen is, let's say you have multiple databases, 20 databases. Okay. Altogether, at this time, the peak usage is 60. Here it's 80. Here it's 90, and maximum usage by all 20 is 100. Okay. At this time. So what happens is you can have an Elastic Pool having 100 DTUs or 100 or maybe 40 vCores, because at this time this database is using 100 here, but other databases are merely using 10. So what you can do is 100 the maximum DTU used by any database at particular given time, and the maximum database DTUs used by all other databases. Just club them together, use that DTU. Let's say it comes 200. Okay, so now under 200 DTUs, you are basically clubbing all these databases together. Here, if you have 20 databases and each of them uses 90 DTU at one particular time, you will have to have 90 multiplied to 1800 DTU. You will be charged for 1800 DTUs. Here, you will be just charged for 200 DTUs. The best use case for such kind of elastic pool is for the people who provide SaaS applications, software as a service, where they host their client databases back themselves, right? So what happens is, so each client may have different kind of database users, right? At one time, one may be using a different kind of database, another using maybe the different kind of database. It's Salesh, you asked the question, what are DTU and vCore? Okay, so I think your question has been answered by now. Let me know if not in chat. Sorry, I didn't chat that earlier. So, okay, so that is how the elastic pool helps you. Now, serverless. So serverless is the compute tier. So what happens is, in serverless, you choose the maximum and minimum configuration, vCore or DTUs. Oh, sorry, it's only available in vCore. Let me again take you back there quickly. There you go. Go to general purpose and serverless. Here, you give maximum vCores, you give minimum vCores. So what happens is, by particular time, that if your server uses, you have unpredictable workload here. You have a server, and that server is used for just, let's say, testing purpose. Or you have an application which only pulls users at one particular time. Okay, let's say it's a Pizza Hut application and a particular area. Okay, so people will only have pizza between, I guess, the maximum 6 a.m. until maybe 11 night, right? After 11 night, between 6 a.m. your application is ideal. Okay, if you choose a straight, that provision compute, you are charged for 24 hours. In serverless, what can happen is you can choose something called auto post time, right? So you can choose that, okay, I want my database to go ideal after waiting for 1 hour. Now, what it will wait for? It will wait for the new connections. If there are no new connections, what will happen is that Azure will take away all compute resources. It will take away the vCores, it will take away your memory. You will only be charged for the storage you are using. Okay, because storage is something it cannot take, because it contains your data, right? It cannot take away these. It can take these because this is something which is not dedicated to you, right? It can give you the vCore for somewhere else, right? So that is something serverless is, where if you have a database or set of databases which has unpredictable workload, let's say these are inactive at this time. So your auto post time may be 1 hour. So what will happen is, let's see, connections have been dropped here. There are no connections. Okay, after 23rd, 11 p.m. Okay, it will wait for 1 hour here. At this time, it will take your database down. Okay, now you will only be charged for your storage here, not for compute. So you are saving money here. Now what will happen is, guys, your application should be built in a way that whenever it will come and try to connect to your database here, since database is ideal, there are no compute here, all right? Just storage, your connection will fail. So it takes around a minute or so to come this back online. So first initial connection will always fail because your database is ideal here. Once you start, your application will start connecting, it will take a minute or two to bring this database online. At a time, it will start. Okay, remember one thing, since your computer is taken away, your cache is clean, everything is clean. So initially, some of your queries may feel degraded performance. Give me a second, guys. Okay, so I guess you got this point, guys. So this is our serverless. Okay, now hyperscale. Now what happens is, serverless, all other than hyperscale maximum supports up to 4 terabytes, right? Hyperscale supports up to 100 terabytes. Okay, it is again only available in vCore purchasing model. It provides nearly instantaneous database backup because it takes a snapshot.
The backups are based on file snapshot, and those snapshots are stored in Azure Blob Storage, and even the files are stored in Azure Blob Storage. Okay. Now it provides fast restores because backups are snapshot based. If you want to restore a database, it will just have to restore that entire snapshot. That's way faster than restoring a 50 terabyte of database file. That will take hours and hours, even days. If you guys have terabytes of databases, you must have seen. So I have almost 15 terabytes of database in one of my SQL server. That takes more than a day to restore. Okay. Now, if we are restoring full backup, for sure, it provides a greater performance. Okay, because the way it is built, the way its model is, we'll see how its model is. Okay, it provides faster transaction coming time. It provides higher transaction log throughput. Okay, it is scaled rapidly. Okay, you can have one primary and up to 3 secondaries, and those can be readable secondaries. Okay, you can offload your read workload. 2 replicas are created by default, but can be upgraded to 4. Okay, yeah, auto growth is basically when the database, let's say you are using 80 gig right now, and your database is in Hyperscale. Every time you will require you are putting more data here. Every increment in your data file is by 10 gig. That's the default growth for your database each time. Okay, the pricing is computed based on each replica. If you have 4 replicas, you will charge for 4 replicas. Okay, now your Azure SQL traditional database can be moved to Hyperscale, but if you are in Hyperscale once, you cannot move back to your traditional database. If you are moving to Hyperscale, just make sure that you know what you are going to do, right? Now, this is the architecture of Hyperscale. Now, what exactly does this Hyperscale, this architecture show you? You have multiple stuff. Now, the multiple stuffs here are these compute nodes, page servers, blob storage, log service. Now, this is a critical one. To understand this, guys, your application connects to your compute nodes. It's not a traditional architecture, right? Where you have a server which contains its disk, and that contains a SQL server contains everything. No, here this compute node contains SQL servers. This compute node has its own cache that's called RBPAX. Now, RBPAX is called resilient buffer pool extension. Now, what is it used for? It is used for keeping it keeps your buffer pool here, right? Your database is here. It do all computations here and everything. All right. Now, what happens is when you connect here, you run your queries. There is something called log service. Okay, all logs are sent to log service. This is a multi-tier architecture, right? Not a club architecture. So here what happens is the logs are sent here. Now, SQL engine doesn't care whether these logs are lost or not. That's why no matter how big these logs are, in Hyperscale, you never come across those issues which you may have came across on your on-prem. Those called database transaction failed because the transaction log for XYZ database is full. Please free up the space, right? You must have came across those issues. You never come across here because virtually the log space is infinite, because there is altogether different service which uses different service, different technology to handle all logs. So what happens? Your queries comes here, logs are sent to log service. Now log service has its own cache where it puts those logs in, and this is several gigabytes, not just meg. Okay, guys. Now this is something called landing zone. This log service puts those logs in cache in landing zone, and this landing zone keeps logs for long term for crash recovery and everything. Now from landing zone, logs are sent to your long-term backup for logs, and these long-term log backup are used for point-in-time recovery. Okay, now you have something called page server. Now what is page server? Page server is a logical layer. It's even a physical layer. I wouldn't say logical layer, but abstracted logically from your compute. Okay, so here you have RAM, here you have your cores, your CPU, here you have page server. Now what page server is? Page server is another different service specifically for Hyperscale. It's a service which keeps your data pages. Okay, now your compute doesn't really pull your data from data files. Now data files are stored in blob storage. It never pulls this. It checks page server. Okay, the data pages are first kept in page server. Now so one primary, multiple secondary. Each node has their own page servers. Okay, now it checks for the pages here in page server. Now each page server can contain the minimum amount of memory, minimum of data the page server can contain is 128 gig up to 1 terabyte. Okay, and one server may have multiple page servers. Okay, so pages are checked here in page server. Again, page server also has its cache. So guys, understand one thing here. When you are trying to pull pages from page server, actually page server is giving you pages from the cache. So this is the way, this is that performance which you get, the extraordinary performance in Hyperscale. Okay, because there are one cache, two cache, three cache. Okay, now if data isn't available in page server, then page server goes to blob storage, pulls data from data file, puts in RBPax cache, and then puts in the nodes RBPax cache. Okay, that's how it's all done. Now, another thing, when we set backups, we set snapshots of file. Now, the backup isn't taken here because we don't have database here or here. We have pages here, but don't think it's entire data. Data is here. These are the database files. Now, the snapshot is taken here. Now, guys, when we run backup in our RDB, in our SQL Server on-prem, that puts a bit of pressure because everything is living at one hardware. Here we have things on different hardware, right? So your backups are taken from here. So your compute never experience that kind of slowness by the backups. All right. Now, these snapshot, if you want to restore, just replay this snapshot, and this is like lightning fast. Even for 50 to 70 terabyte, it just takes few minutes to restore. All right. So this is a Hyperscale architecture, guys. I hope you understood it. Okay. Now, managed instance. These are the fully managed PaaS offering with broader SQL Server engine capability. Okay. After Azure SQL in virtual machines. Okay. Now it has nearly 100% compatibility with latest SQL Server engine. It doesn't provide DTU support. These the managed service only provide they only support vCore based purchasing model. We have general purpose and business critical there. We have VNet security. You can have your NSGs. You can set up your rules in NSGs on IP addresses, on kind of protocol, TCP or UDP or whatever you want, on port numbers. Okay, you can use NSGs in VNets to control your security. That's really great. You can have what do you call them, routing tables, okay, to secure you there. It's the best PaaS service for lift and shift again with minimal. I didn't say no code chain. In Azure VM, there is almost no code chain. Here, minimal application and database changes. Okay. You can use BYOL with your own license here. Okay, it supports TDE, Azure authentication, single sign-on, auditing, and automatic advanced threat protection. Okay, you have managed instance pool. Guys, we do after the 1.5 hour. I hope you guys are not feeling bored. Hey guys, you are feeling bored or you have any question until now? Let me know. If you are understanding, then also just quick shout out if you are getting it. Yes, no, okay, no problem. I hope you are still with me, not sleeping. So, okay, give me a second. Okay, yeah. So, instance pool, as I said, it allows you to pre-provision compute resources. It will spin up a big instance based on whatever you choose. You know, the model, the number of vCores, the storage and everything. Okay, you spin up a pre-provisioned compute VM, and then you create your managed instances inside that. Okay, you can create, so usually single instance, the minimum number of vCores are 4. And managed instance pool, you can have an instance of 2 vCores as well. Okay, the total storage in one pool can only be, maximum size is 8 terabytes. Okay, if you have 2 vCore instance in an instance pool, the minimum storage can be 32 gig and a maximum can be 640 gig. For 4 vCore instance in instance pool, minimum size, maximum size. Okay, the maximum supported number of databases. This is a bit of insights I'm giving you guys, not just overview, because you may find this information difficult to find on Google. All right, so this will be kind of inside information. If you have 8 vCores of instance, okay, that supports 200 database for instance pool maximum. Okay, if instance pool is of 8 vCores, maximum 200 gig, 200 databases, 100 databases per instance, then you can have multiple instances within 2 vCores or 4 vCores, 2 4 vCores or 4 2 vCores or 2 vCores and 1 4 vCore, whatever you want. Okay, 100 database per instance, 80 databases for 2 vCore instance. That's cap here. If you have a 2 vCore instance, maximum number of databases can be 50. For 60 vCore instance pool, maximum database are 400. For 24 plus vCore, 500 database. Okay. The one catch here is, guys, you cannot use Azure Active Directory authentication with managed instance pool, because what happens is that we cannot set up AAD admin on instances which are deployed inside managed instance pool. So that's why we cannot use Azure Active Directory user to authenticate to our managed instances within instance pool. You can still have AAD admin to manage your complete pool, but not the instances within the pool. Okay, you can only use SQL authentication there. Now, only general purpose service tier is supported, and that's also in PP, public preview for instance pool, not business critical. You cannot use scale because still this is in PP. Cannot create port using portal because again it's in PP. I mean public preview. It's not GA yet. Okay. Once you create instance in an instance pool, you cannot take them out. Or if you have created a single instance outside, you cannot brought that into pool. That's a limitation again because it's in public preview. Okay. The pricing. How the pricing works. The vCore price is charged on pool level. If your pool is of 16 vCore, okay, no matter you have just one VM of 2 vCore inside, you will be charged for 16 vCore. So make sure if you are creating a managed instance pool, you are pre-evaluating everything. Make sure you are exhausting all the resources with you, whatever you are putting in your instance pool. All right, and the storage is 32 gigabyte, which is free. For 32 gigabyte in each instances are free. Okay. Now, HADR options, guys. What HADR options we have in Azure SQL? For virtual machines, we have disks. Now, Azure keeps 3 copies locally. Now, why we say locally? I will tell you why locally. Okay. So Azure keeps 3 copies locally of your disks for your Azure VM. Okay, and these disks come from the RAID level. So this provides this kind of HA here. And DR, if you are RAID 10, you have HA, you have DR there, okay? And HA as well, because that does mirroring as well of your disk, okay? Now, inbuilt HA, always on failover cluster instance is supported via premium disk and ultra disk, okay, Azure shared disk. Always on availability groups can be done, but within same region, okay? Now, SQL Server data files. What happens is you can push your on-prem SQL Server data files back to Azure. Okay, this isn't something HA for Azure VMs. Now, DR, you can configure log shipping, mirroring AG from your on-prem back to Azure, and you can take your backup to Azure. These are some HADR, stuff which it provides you. Azure provides you for the VMs. You get Azure Site Recovery. Now, what happens is your on-prem VMs can be a part of Azure Site Recovery and be replicated to Azure to provide the HA on-prem, and even your Azure VM can also be part of ASR and can be moved to another region if needed. Okay. Now, if you have VMs in Azure SQL, sorry, if you have your SQL Server machine in Azure, you have your SQL Server running in Azure VM. I said locally. Azure gives 3 copies locally. Why not on multiple zones, multiple regions? Guys, if you have a database, you have this database which contains multiple data files, okay, and the data files is on each disk. Now, what happens is in background, the synchronization is async. Okay, each disk is synced in region or another zone. Now, if you have data files here, so it may happen that these three synchronizing agents may be synchronizing your disks to another region at same time, but this agent may be lagging behind. Now, what happens is on the second region, your database is not consistent, right? Now, if something happens, the data file which is in on this disk is behind these disks, right? So that's why the synchronization, the non-local, I mean the geo replication of data disks for SQL Server databases is not supported, because your data will never be in sync, because the process is async in background. Okay, if you have your all data file in one single disk along with your log file on single disk in Azure VM, then you can use non-local, replication of your disk file, your VM disk. Okay, that's one limitation, guys. You need to understand. Now, HADR, built-in HADR option in Azure for Azure VMs. The earlier HADR option was for on-prem back to Azure or even Azure, but this is specifically for Azure. You can have free VR replicas for your Azure VM via software assurance. Now, what is software assurance, guys? So, software assurance is a MOU between you and Microsoft. Only the big guns, with your giant companies, like does a lot of business with Microsoft, those falls under the category of being partner in software assurance.